Hey, so our first topic is going to be C++ templates. So before we do anything, can everyone go onto this URL, codeboard.io, sign up, and create an account for yourself, because we're going to do live coding in our tutorials. Just to make sure that you can do it. Does everyone have this ready? I'll wait for a few minutes. Is everyone ready? And I'll get started. So first question, what are templates? Outside of programming, templates such as a template for a resume. It's just a template where you just need to fill in your name, your experience, your education, and everything else that you need on your resume, and that's just a proper resume. And you can reuse one template for multiple people. It's similar for C++ templates. And in this tutorial, I'm going to introduce you what are templates, how can you write a template in a function template or a class template, and when should I write a template. So templates are used as something called generic programming, which is helps you to write a code once, and you don't need to write it for other types. Like if you write it once, that it will work for all of float, integer, character, string, and everything else that you need. And what can be templated in C++? I'm going to cover functions and classes and some other stuff. For function templates, let's consider a common function swap, where you're having two parameters passed by reference, and in this function, you're just swapping the values in them. And these two functions are written together. Both are named swap, and they do the same thing, but the difference is one is in int and one is in double. So question, why will this compile, why or why not? And I'm going to give out chocolate bars first. You can answer it. Anyone wants to answer it? Will this code compile? Yep. And why? Yeah. Because the function will be called based on parameter types. And this is called function overloading. What if I want to implement swap for all types? Well, the option one is obviously to write a function for each type. And in this case, it won't support the other types that you don't want. And this is kind of a safety feature because you don't want like anything to call your function in some cases. But in this case, you will need to write a new swap function for each new type. And in the process of copying and pasting the code, you may make mistakes while repeating the code. The other option is to write a template where you can change the type. And in this case, you can support all of the types that compiles, and it avoids the copy and pasting and duplicating code. But negatives, it may cause longer compile times. And this is how you will write it as a template. The first line tells the compiler that you want to use templates using template, and you define a type name type. So this type will be replacing the type that you are having before, such as integer or double. And then you write the function where you are replacing the int, the double, with type. If you have this swap function will work for all of integer doubles and everything else that has the operator equals defined, because this is the operation that you are using inside here. And that's the only operation you're using for this function. And note that A and B must have the same type, otherwise it won't work. Does that make sense? Okay. How would you use it? This is an example of how you would use it. So first, you have two integers, I and j. So the first print statement will print out I equals to 5, j equals to 9. Then you call a swap of I and j. And after that, the print statement will print I equals to 9, j equals to 5. They are swapped. Same thing for double. Before the swap, it will print x equals to 0.5 and y equals to 4.6. And after the swap, it will print the swap values. And in this case, you are defining the swap to explicitly use double. So in this case, if you say swap double I and j, it won't work. Okay, another chance to get chocolate bars. So we have these variables and these cases. So for each case, does it compile or does it not? And we have this swap template. Yep. You can do one of them more. Yep. Anyone else? Yep. Why? Mm-hmm. Who wants to answer the third one? Yep. Mm-hmm. The fourth one? So first one, m and n are of the same type, so they will compile. Second one, the integer and char are different types, so it won't. Third one, no, because it requested for double but given integer. And fourth one, yes. And the last one, no. And next, I will ask you to implement a template minimum function that takes in type A and B of the same type and returns the one that has the minimum value of the same type. So I will be asking you to split into groups of 2, or if you want to do it individually, you can. Go to this URL and complete the code under exercise 1.h. That will be a minimum function. And check with compound wrong. And let's get back in 4 minutes. So we won't grade this exercise. It's just for you to try. Okay. Let's check the code. So given a type A and B, we first check if A is less than B, then return A, otherwise return B. And when they're equal, they are both the minimum value, so return either of them. So next thing to consider, when will this completed function compile? Templated function. So first, because A and B needs to be the same type, so when exactly one type is used, just like swap. And the second, when the operator less than is defined, because we are using the operator less than to compare the two values. And when is this not defined, like some arrays and some other types that are not meant to be compared, of course. So that's it for function templates. Any questions till this point? Yeah, should be straightforward. Next is class templates. What would you template inside the class? Like member functions and member data. And those are the two things that you will have inside the class. For example, the array plus the linked list class that you should have wrote in 244, a binary search tree class, can all be templated. I'll be starting with a simple example of pairs. So for a pair, it will store two pieces of data together. It can be, for example, a key plus a value. For example, a key can be a name and a value can be a student number. And if you are putting them inside the binary search tree, you might want to be like make the tree be searching by the key, and for each key you have a separate value for it. And let's create this class that can store two pieces of data called a pair. And this pair can be inserted to any data structures like binary search tree. So here are the specifications. You want to have two members, the first and the second, and they can have different types. Like it can be a string and an integer, can be a double and a string. And here is the function prototype set header class for this. So first, template, and you can have more than one type templated. So we're having type name, first type, and second type. The class pair, and you have the constructor, the setters and getters, and the two private fields, just like how you would write a class. And this thing, a thing to be noted is that the function definitions must be in the header file. You cannot put any function definitions in the .cpp file in this case, because the compiler needs to recognize everything inside one file for templates. And implementing it inside the class pair, you just do the same things and implement everything in the header file, like the constructor and the setter and etc. And to use it, you call a pair, declare a pair with type int and float. And in the constructor, you do int and float values. And you can use the getters to get them. And this one creates another pair that takes a string and a double. And you can make it with a string and a double, where first is the string, Mario, and the second is the double. Make sense? And you can use the setters and getters to access the numbers. And in this case, you will need to define the types here explicitly. Okay. Next, I'll be doing a demo on it. Let me pull over my CG. So in this folder, I have a makefile and my max.cpp. Let's first take a look at the makefile. Is it too small or is that okay? Yeah, so the first line, we have the line conf equals to debug. And that's the build type that we want to use by default when you call make, when you type make. So for the configurations we're using, we have the release, the debug, and the debug check. And I'll be covering that later. So this is just defining the compiler to be G++ and your compile flags to follow. You won't need to write this file, but you have to be able to understand it. So you have the clean, make clean, and the make help commands defined, and yeah. So for the configurations, we defined the release, debug, and debug check in here, and all of them are done with different compile flags. And now let's look at our source code. So this code, what we want to do is we have a templated function max with type t, and this returns the maximum value between A and B. Let's do make. And this is just one example of the code cannot compile. And by just looking at the compile messages, you may get a really long error message, but don't panic, just go to the first error and see where this is caused by. And it's saying there's no matching function for call to double and int, and just go to that line. I'm just using Vim, so it works for me. So go to line 17, and this is the problem. So I'll just make the 2 into a double by making it 2.0 and make again. And double check the print values. Should be right. So this is just an example of how to debug with compile errors. Usually the compiler will give you a really long error message, and the really useful stuff is the first error. And after that, it's just giving you suggestions. So the point is to not panic and go to the first error. Let's continue. So the tips for writing templates is first, don't write templates by yourself. And in this course, you won't need to write it for the most of the times. And you will be using them written by other people in the standard template library. And in the rare case, if you do write the template, first make sure that you write the code for one type first, like for integer. And you test it and make sure everything else works, then replace all integers into type, convert it into a template, and test again with multiple types. So this way you will be breaking a more complex problem into smaller problems, and you can solve them one by one. Any questions on templates? So that's the first part of our tutorial. And I think we finished early, so we can have a longer break. Let's get back by 11 for the second part. The error message. Yeah. No, it's not on the slide. Demos.
So, like, respect them.
The call is here.
So we pass the argument text and 2.0, I believe there are two doubles.
Yeah, this is I fixed this afterwards. But before that it was XP. Yeah.
I have a question about you shared that template so that in the slide is that here that one also
Just say they should be in the same file, so you cannot split them into header files. So if you have them in the header file, usually we want them in the header file because we want everyone else to use it. But you can put it in the CDP. It's just you can't put part of it in the header file, part of it in the CDP.
Oh, so it has to be
Yeah.
separate from
Number one. Yeah, oh, yeah.
How often do you practice? This one has But this side of this.
Yeah, but I get the experience. Go ahead. Bro, the other one, I wanted to intro, but because it's a minute, software, it's like, everything that you want about bro, it's like, once there was 200 listening and I'm like, oh, so I have a friend where like now my science team is why right now he's working at so I saw some stuff it's a quote and by applying this job you would also be considered good quality. Janitorial staff, fair club, some way over. And basically all of them. And apparently that's oh, here's my products, and then you're like, you do something.
Okay, everyone. It's 11 and let's get back. So before we start the second part, you may notice that I brought these mega blocks here. So what I want to do is that I want to challenge you. Can you build a house faster than me? So for a house, we want to ensure that we have 4 walls and 1 of these. So now I need 3 of you to come up and compete with me. Yeah, raise your hand if you volunteer. Yeah. And who else? Who else wants to come up? I need 3 of you, and I'll give out chocolate fountain. Yeah. One more. I need 1 more. Oh, yeah. Yeah. Okay. Even though it's gonna beat me. I have to talk about it. Yeah. And that's a good thing that you. Have you noticed that I just brought out these? Yeah. Because I keep. Good job. What was the point of that? Yep.
You have a pre-made template of a wall, it's easier to make a house.
Yep. And for you, it was building from the smallest building block, like writing your own classes, your own templates, your own everything. And for me, I was using a pre-made library where I was calling wall, 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 wall. and roof. And there's another point to that. And what was that? So what will you remember the most after this tutorial? Yeah. So it's something mentioned in your Make Stick book. And this is a communication skill that you can also use in your own presentations. And yeah, let's go into the second part which is the standard template library, or STL, standard template library. So this is the template library that's built into your C++ compiler. And in this part, I will show you how should I use the STL and an example library, example structure that is useful for you, which is the vector. So writing templates can be difficult, but we want you to use it. And using templates is much easier and much productive. The STL has all of the basic templates that you would think of, like swap, sort, the pair, and the min that we just wrote in the previous part, and much, much more. The containers library makes the containers or data structures available to you, like the vector, which is a dynamic array of elements of some type, and lists, a doubly linked list, some type. And they are templated, which means that you can specify the types when you are declaring them. So why do we want to use STD vector? For example, we want to read integers from the user, like from a file or from the cin until end of file. So until Control+D means end of file when you are entering through cin. Then we do some work on the array, but you don't know the exact length of the array. So how big of an array should we allocate? We won't know until we read in all of the inputs and we see the end of file character. A solution that you have used in 244 is linked lists. But lists are insufficient. For example, if we want to access element n, you will need to go to the head and go next, n times to find the element n. The better solution is to get something that can work like an array, where you want to access the element n and you just say, go to the element n and grabs it in O1 times. But can grow dynamically, which means we don't need to have the exact number at the beginning and you can insert anytime, which is the vector. So for vectors, you can access and modify the elements like as you would do in arrays with the operator brackets, square brackets. And to insert a new element, just do push back. And this will push a new element to the back of the list. And if you want to find the number of elements, just call size, and this will return the size of your vector. So, for example, if you want to read something, read the integers from some input string, first use the header include vector to use vector, and this function wants to return a vector of integer. So inside this function, make a empty vector of integers here. Then you do the while stream. It's not end of file. So this case, it will enter until it reaches a different value or an error. But in this case, I will just use the while stream inputs to value and push back value into integers. Then at the end, return integers. And the pushback is just pushing the integer element into the vector, and the vector will grow. So this is the input, and next I would like you to write a print to print all of the elements in the vector. So let's go back to code board, this project. It should be the same project, and complete the code under exercise 2.8. And we'll be back in 4 minutes. Everything good? Can everyone do it? So this is the code. So first get integers from Cint, and to print all of the integers inside integers, we do a for loop, and I starts from 0 to size -1, and print out integers I. And that's it. In this case, we'll be printing the elements inside integers separated by space. So how does vectors actually work? This is the get integers function, where we are reading and pushing back values into the integers array. Let's trace it. So first, this is the code that's that's behind the scenes, that's not shown to you. So first, we have an integer array in pointers, and the size is 0, and we have a capacity of 3. During the first pushback, it will increase the size and write 1. If that's the input. Then let's continue to the second input. Pushing back the 3 increases the size and writes the 3. Then 8, increase the size and write 8. Then at the 7 input, we see that the capacity has been, that the size equals to capacity, and we can't just add 1 more. So what vectors will do is that it will create a new array of capacity 2 times size and copy over what initially was in here. So it will create a new capacity of 6, and it will copy over the 1, 3, and 8. Then it will delete the old array to avoid memory leaks. And now you have a new array of capacity 6. So the complexity of this algorithm is not as much, actually. Yep. It was just an arbitrary value. It's usually a factor of 2. Yeah. So when there isn't enough space, the capacity will grow by 2. But for a larger number of n, it's actually not that much because it grows by log of n. So on average, the pushback function has a 1 complexity, actually. It will be a little bit slower than arrays, but it's not that small. It's not that slow. So vector has 3 different constructors. First, the default constructor that creates an empty vector with size 0. Then a constructor that takes in 1 integer that says we want a size of 10. Initially, it has a size of 10 with unspecified values. And we can give 2 parameters, which is the first one is the size and the second one is the initialized values. So these are just three different ways of creating vectors. And this slide is just showing you how different are C-style arrays and vectors. So both of them are creating 10 copies of integers at the beginning. A and B have A and B are arrays and V1, V2 are vectors. Accessing the elements are the same. Then creating copies. First question, what happens when we do A equals to B here? Yep. Yeah. So it does a shallow copy and causes memory leak because nothing is going to be pointing to the original A. Now, what happens when we do V1 equals V2? Any volunteers? Yeah. So it's a deep copy. Each fuse element will be copied to V1 and no memory leak. We don't have to. They are not pointers, and all of the creation and deletion are handled by the library itself, so not us. And usually when we are programming, we just want to generally avoid pointers because pointers are really error prone and they can lead to memory leaks. If we're just using the library, we won't. But just use pointers when they are absolutely not avoidable. But there are also problems with vectors, which is the bound checking. The operator square brackets does not create values and they do not check bounds. So if you are using out of bound indices, if you are reading them, the program will run, but it will give you garbage values. If you are assigning values to the out of bound indices, your program will crash with segfault. So in your milestones, if you see segfaults, it's a really good thing to use the debug check configuration in your make file. And this will help you do bounds checking and see if any of them is causing problems. Yeah, so it's just, but using this will have efficient random access to data with O1 complexity. Next, I'll show you the second demo. That's that. So we have this program, this source code. Where we have n equals to 100 and we have a vector with 100 elements, but we're accessing up to 105. Let's do a make and see what this does. Notice that there is no compiler errors. So it will print all the way up to B0105. And these last 6 values are garbage. Okay. And no error checking were done. The program just finished successfully. But do we really want this? No. So instead of the original make, we compile with configuration debug check. Before that, we need to make clean to remove any previous compiles. And let's run it again. So this time it runs up to 99. And at the out of bounds, the bound, it will give out the error message saying that we are accessing things out of bounds. And this is why debug check is our friend. But why do we usually don't want to use it? Let's do a timing demo on this. So we have this file. We don't need to actually know what exactly it does. It's just doing and outputting for a really large n. This is for timing purpose. And let's take a look at the make file. So make file originally has configuration debug. Let's make and time it. Do a time on that. So this is the output from the time command from Linux. So it just tells you how much time it's spent in the user mode, in the system mode, and the total time, which is 1 second. Now let's try it with release mode. And notice what I'm doing is that I'm just pressing the up arrow so that we can reuse the old commands in Linux. So when compiled with the release, we can see that we are only spending 0.46 seconds, which is a lot faster than debug. Okay. And finally, let's check with debug check. And time it. See how slow this is? 6.7 seconds compared to 0.46. Okay, the last question is how fast is Python versus C++? Hello, let's double check. So we have a Python file in here that's doing the exact same thing, except it's in Python. And when you are writing it, it's really convenient because it doesn't need any types or anything, and it doesn't need a compiler. And let's just time it. See how long this is? 24.3. So Python is really, really, really slow. It's even slower than debug check. Okay, let's do another experiment. Remember in release mode, we have 0.46 seconds for vectors. And let's comment out the vector and use the array instead. And we do make release. So what do you expect the result to be? Will it be faster or slower? If we do, instead of vectors, we do arrays. 0.44. A little bit faster, but not much. And depending on machine load, 0.44 and 0.46 can be seen as the same numbers. So vectors are not slower than arrays. They are a bit, but not noticeably slower than arrays. And yeah, how much do compiler optimizations impact runtime? Releases a lot faster than debug and a lot faster than debug check. How fast is vector versus arrays? They are about the same. How fast is Python versus C++? Python is a lot slower. Go. And that's it for today's tutorial. And here are the books that you want to learn more if you want to learn more about C++ and the STL. And online, you can also find resources on Google and these websites. Any useful STL containers that you will need to find them on Google. Okay. Yeah, come up if you have any questions. So you can't just do, for example, here you push back one value, which means that your vector has size of 1.
Yeah.
But you do v1 1, otherwise this will crash.
Oh, I see.
Yeah.
Yeah.
It doesn't increase the size. Yeah. The stream is an I stream, input stream. So it's like C in or F. If you do a IF string, that's FN.
So here, just compare.
Here it's this is the operator of the simple string.
Oh.
Yeah.
So the vector to all faster.
Arrays are slightly faster than vectors, but it's usually not noticed in real life. So we do say that they're the same.